This is a summary of the 2007 handbook chapter called Probability in Research, written by Jones, Langrell, and Mooney. Upon reading the chapter, two main themes emerge: learning goals from curriculum and the role of the teacher in partnership with curriculum. When you look at curricular learning goals, some interesting issues arise. One of these is the word choice in the curriculum document itself, as some pose to offer better advances in learning than others. The second is a lack of specificity in certain aspects of curriculum, making their direction and goals unclear and unfocused. Then we examine the pairing of teachers with curriculum, and several aspects of teacher knowledge become apparent. This raises the question, can you teach what you don't understand? This is the focus of the first half of the chapter. It compares learning objectives from 3 international curriculum documents published at around the same time between 1990 and 1991, and they come from Australia, the UK, and the United States. We start with the elementary curriculum. First, let's look at the standards for Australia and the UK. They offer very similar objectives. They offer understandings of vocabulary and events, as well as developing the idea of sample size and probabilities. Possibilities. The United States standards and ideas are very different. Students are introduced to uncertainty through games and paired this understanding with very casual language. I'm going to point out the word luck and let you take your opinions from there. Then students learn to compare likelihood, which must be stated for them, either in qualitative or quantitative terms. And they take these measures and compare likelihood of outcomes. As we progress to the middle school ideas for probability understanding, we continue to see that Australia and the UK are offering more pronounced concepts to learners. They're also offering more pronounced formalized goals like constructing and analyzing sample spaces and developing an understanding of relative frequency of compound events. In the US, the goals are still very vague, but we do offer opportunities to start to develop crucial understandings by modeling ideas. In high school, it seems like the ideas continue along the same path that they've been on. The Australian and UK ideas offer students opportunities to explore different types of probabilities, like the Poisson distribution, highlighted in Australia, while the UK allows students to understand compound probabilities and different distribution shapes. In the US, we finally start to go in a more formal direction. And one of these ideas that supports this formalization is the use of simulations to model probabilities. We're also digging very deeply into normal probability. This still leaves students very far behind their international counterparts. This marks a transition to the second part of the chapter. The main ideas here are how teachers design and interact with the aforementioned standards. And it was introduced and framed with one quote. The success of any probability curriculum for developing students' probabilistic reasoning depends greatly on teachers' understandings of probability, as well as a much deeper understanding of issues such as student misconceptions, from Holly Lynn Stoll in 2005. When we take this quote apart and start to understand what it truly means for teaching probability, 3 main ideas come out of this discussion. One is mathematical content knowledge, or how well teachers actually know the content they're supposed to teach. Pedagogical content knowledge, knowing how to present the material, and knowledge of student intuitions, knowing your situation when you're teaching and where your teaching could lead students astray. These areas are lacking in research despite a 1992 call for further research in this area from the 1992 handbook chapter. One of the posed reasons for this unfamiliarity is the relative youth of probability. Just to put it in reference, Thanksgiving has been around longer. We start to see an emergence of probability in philosophical writings and correspondence between figures, such as Pascal and Fermat, around 1650. But we don't see the first formal publication of a text relating probability in mathematics until 1718, when de Moivre published the Doctrine of Chances. We start to see a formal push to include probability into all levels of curriculum in the early 1990s. There's also a case made for generalizing probability to social situations to help make it more familiar and accessible to students. What we have here is a presentation of a task that was adapted to a social situation. One of the weird things here is just changing the question and changing the wording of the task, change the meaning of the task. I'll leave you to ponder that one. We can dig into it a little bit deeper. One of the other main goals for this chapter was to outline how curriculum should frame an idea called probability literacy. It's a very broad topic, but the authors have narrowed it to include some key points. One of these is an integrated understanding of probability, both conceptual and procedural, as well as a need for blended sources of information, not just frequentist or classical, but drawing on student experiences as well. There's also a call for more formal language and terms within teaching of probability, as well as asking students to engage with questions and question sources and material posed in those questions. So the question is, how should this inspire instruction? And the chapter also gives us several examples of what that could look like. One of these is Watson's questioning of media claims by students based on understandings and ideas about probability and statistics, published in 1997. Another is the use of richly contextual problems, which draw information from several sources, like frequency, classical information, as well as student experience. One example is Gal's insurance scenario. While not quoted and referenced, it is very exemplar of the goal of the chapter. Another idea presented is developing intuitions in a genuine style. This is proposed by comparing distinct events with how often they occur, like how often does Tuesday follow Monday, and helping students develop that meaning. This brings us to further directions for research in probability in education. Based on the first handbook chapter published in 1992, several areas were identified as lacking in the research. We're going to highlight some of those initial areas that are still lacking. The first area is work with student conceptions. The next is developing inclusive curriculum. Do all children or students understand gambling and games of chance, or can we find better exemplars of occurring probabilities within our field? Then we need to dig deeper into teachers' conception of probability. There's a great body of research that's developed on data analysis, but it hasn't extended itself to probability, nor have we done exclusive work with probability. We also need to look at the role with progression of technology, how it mediates student understandings of probability.